but I always love working with James because he's got more experience with additive manufacturing on the manufacturing side than most people in the world. So I learn new things with him every time I'm in front of customers. So great resource. And George has been doing this in automotive for a long time. So between the two of them, I think there's like 150 years of experience in the automotive industry. Is that about right?
That's just me.
That's just you? All right. Awesome. All right. So, and I want to thank the speakers. We've got Global Vehicle, we've got Eckhart, and we've got Ford. So it's just interesting to kind of walk around and have some conversations before we start because additive manufacturing, Stratasys has been around for 30 years. Cimetrix, JAvelin alone has been around for, I think, 26 years selling this stuff. So we've been doing this for a while, and the industry's been around for a while. And the expectation is that most people, especially in automotive, because it's an industry that's really adopted additive, really has a good understanding of what you can do with it. So it's extremely important that we've got some customers that can kind of give you an overview of what they actually do with the technology, because you hear a lot of stories, you guys from Global Vehicle Systems. They bought the system 3 years ago. It was a debate between another CNC machine or an additive machine, probably leaning towards CNC. Didn't really know what they were going to do with the system. And they were able to get that thing churning pretty quickly and running 24/7. So I won't steal their thunder, but very interesting story. It's things we hear quite a bit. Talking to another one of you out there, looking at it for rapid prototyping. And again, we can help you. They're bringing their tool shop in for this one. We can help you on the tool shop side. There's a very quick ROI in additive. So I'm excited to have some customers come in, talk about what they're doing, give you a flavor for what's going on in the industry. And with that, I'm going to kick it over. Bobby, you're up first. Bobby from our automotive group is going to take over and go through some trends within the auto industry. Thanks, Paul.
All right. So I'm just going to talk a little bit about what's coming and what's happening today and what's coming in the future as it relates to automotive and within the automotive industry. But before we do that, let's talk a little bit about the past. I think a lot of people in this room understand that 3D printing can be used for rapid prototyping. That's being done today. It's been done by Stratasys and others for the past 30 years. But I'm still amazed, and I know a lot of these guys who go into customers don't really see it as often as we should, where people are fixing mistakes that could have been caught much earlier in the process by either printing a part for design verification, or printing a tryout part or a surrogate part. These things can really save companies money, and the earlier that you get into the process, the earlier that you find out you've made a mistake in the process, the more money you save, right? So that's sort of the past of additive, right? I hesitate to just gloss over it because it's still so meaningful and impactful for everyone to think about design verification, surrogate parts, tryout parts. If you print a version of your production part and get it into your plant in advance of the production parts showing up, your fixtures can be done, your tooling can be created, your operators can be trained, your inspection equipment can be created, your programs, your robots can be figured out. Everything can be done with a simple prototype, simple print, just a mock-up of the production part to come, whether it's a casting or an injection molded part. So I just always want to hit that for everyone. There's still opportunity for a lot of automotive folks to implement additives simply for the prototype side. So let's talk about what's happening today, and this is probably where okay. I'm not going to PowerPoint you guys to that. Just one slide. So this is what's happening today in automotive. And what's happening is we went from that prototype stage to the tooling stage. Now James is going to talk a lot about different types of tooling applications, so I won't get into the weeds on this until James gets up here and kind of walks you guys through it. But what's happening is a lot of these automotive OEMs and their suppliers are getting into jigs, fixtures, tooling. And the way to do that is to take full advantage of our equipment, is to put these machines into the plants. So what you're seeing there is not just which OEMs have machines. All the major OEMs have equipment and they're using it all the time for product development. But what you're seeing here is the plants that have our equipment. So Ford, for example, who's going to speak later today, they have one of our pieces of equipment in every single powertrain plant in North America. They're using these pieces of equipment and these machines to solve problems quickly. So you have a jig that you need for a bonding operation. You can design something and print it within 5 hours and get your shift up and running more efficiently. The ideas come from the plants, and so you want to have equipment there locally in your plant to execute and problem solve. Now, that's not to say that you can set up all these huge manufacturing centers in every single plant. Most OEMs and suppliers are doing what we call a hub and spoke model, where you have all of the large pieces of equipment and the heavy investment is in a single location, and then you have sort of offshoots of equipment out in the plants. This is a trend that we're seeing, not just with OEMs, I know this isn't after OEMs, but the major suppliers, almost all small, Garcia, etc. A lot of the suppliers are doing the same thing because they want to be able to solve problems quickly. What kind of problems? Maybe we can talk about that. And for the most part, they still have their product development teams. They're sort of dividing up the equipment that they have into manufacturing equipment and product development. So this is the trend. This is what we're seeing. This is what's happening in the market today as it relates to automotive. We get a lot of questions about the future, and I'll talk about that briefly. I really want to focus today on what we can do today, what can be done today using additive to save you money, to reduce, to improve quality, reduce cost, all of those things, improve your lead times. This is what's doing it today. The equipment and the parts that you see in the back are all representative of this type of process and procedure. What's coming in the future and what everyone is striving for is production parts on vehicles. So if everyone in this room is automotive, I assume everyone has some relationship to automotive in this room. Ford makes a F-150 every 53 seconds or so. So until you can take additive from being a 5-hour part to a 5-second part, it's a little bit of a challenge. No one has really cracked the code on this quite yet. If you have some high customization vehicles, it's a great place to introduce additive because assuming you have high customization, you have low volume, that stuff kind of tends to work out. So that's where the market's going. The thing that has changed drastically in the past 5 years has been the quality of the material, the material properties, and they've opened up the application window from just a prototype to tooling. And now we have to address the speed of the process in order to open up a window to production parts. So what's coming down the pipeline from Stratasys? Right now we have FDM technology, which we're going to talk a lot about today. We have a polyjet technology, which you've seen some of the clear lenses and colorful parts. That's our polyjet technology. We just introduced SLA, which is a 30-year-old technology, but we're sort of taking a crack at it so that we can have a full solution for any customer that comes our way. So right now we have FDM, polyjet, SLA. We plan to have a powder-based system. We plan to have a couple of metals options. And that way, when we walk into a company like Magna, we can just say, hey, this is the full suite of solutions. Is your branch focused on small production parts? We have a solution for that. Is this location focused on tooling? We have a solution for that. Working backwards from the solutions rather than just trying to push a machine that can do 80%. We want to have a full solution that can do, hey, we can take these 3 items or these 3 machines and solve all of the problems. And that's all I have. So to get a little deeper into the applications, I'm going to introduce James. He's going to go through a lot of use cases. And while he's doing that, we'll pass the parts around so you guys can really touch and feel. James?
Thanks, Todd. Good morning, everyone. Thank you very much for attending this morning's event. I'm thankful for having an opportunity to share with you some insights as to some of our customers in the automotive industry and how they're leveraging. I guess I'm in the right spot now. If you can queue up my presentation. Number 2, I think. So Paul briefly introduced Cimetrix. I founded Cimetrix back in 1993, and I've been involved with Stratasys, representing Stratasys organization we started off strictly in Ontario, and then we expanded across Canada for well over 20 years. When I started providing 3D printing solutions for our customers, our business was focused on providing high-end design and manufacturing solutions. And all our customers were tool and die mold makers in southwestern Ontario. I'm a tool and die mold maker by trade. So when we started peddling 3D printers, all we knew was manufacturing. And trying to provide that capability within our install base, it was strictly manufacturing. So as much as today we stand up here talking about manufacturing opportunities leveraging 3D printing, we've been doing it for a long time. And there's many organizations out there that have been doing it for 10, 15 years, leveraging 3D printing. And yet here we are in an industry that's roughly about 30 years old, and we're still in front of audiences such as yourselves talking about how organizations are sharing insights as to how organizations are leveraging it on the manufacturing side. So it's just an indication that the opportunities exist, not only for ourselves within this segment, but for our customers or the manufacturing base to really start milking the capabilities of 3D printing. So as much as we've been representing Stratasys for 20 years, it hasn't really been the technology that we represent that defines us. It's really the skill set that we assemble within our team that helps organizations take the capabilities. The technology is strictly just the enabler. It enables us to create solutions that support our customers' business objectives. So building a highly skilled team is critical. Working very closely with Stratasys and their skill sets gives us a very strong 1-2 punch when we're helping organizations achieve their business objectives. So as Fadi indicated, still today, concept models, advanced prototypes, still something that's highly recommended that you invest time to leverage the capabilities. Still a large percentage of our customers will buy 3D printers specifically to support the product development side. We're going to focus more so on tooling things. And before I do that, it's important for you to understand that, is that better? You guys can hear me better? Better? Okay. There are major initiatives. It's not just us trying to share the message that there's opportunities that exist and you should be seriously considering implementing 3D printing within your organization, whether it's in the design department, the tooling department, or out on the plant floor. What we see quite often is the bottlenecks or the challenges our OEM customers are facing is the supply chain is not ramped up or capable of supporting their growth. And sharing the message from the major OEMs, this is the direction we're heading. This is where we need you to be heading with us, because we need you in the supply chain to align yourselves with our business. So it's happening. There are big initiatives. And from Fadi's slide, as far as the distribution of technology within the various assembly plants or manufacturing plants, it's just a start. And it's not just the Ford, the Chrysler, the GM, but there's the Toyota, the Honda, and also the niche automotive makers that are really leveraging 3D printing because of their low volume requirements. So it's happening, and it's the OEMs that are driving it, and you need the supply chain to ramp up. So the tier 1, tier 2, and tier 3 suppliers need to seriously look at how they can align themselves with the OEMs to take advantage of the opportunities. So in this slide, I'm just basically listing out where the opportunities are in the manufacturing side and the inspection, and even on the transportation. And I'm going to be expanding a little bit more on some of the opportunities that we have identified in tooling within the automotive segment. On this particular example, this is a tool that's manufactured using traditional means. We have a 3D printed version of this in the back that I think Fadi's going to pass around. But this is something typical that you may see. It's a weldment with leveraging some purchase components, whether it be a handle, the hoses, the suction cups. But when I look at a tool such as this, that's a weldment, I think, how do they hold it in place while they're welding it? So it's almost like I got to design and manufacture a fixture to make the fixture. So it's kind of a ripple effect. So you have limitations based on the tool design when you're trying to confine it and build it within a specific price range. So there's usually some issues. It works. Is it optimized? Probably not, but it does the job. So what are the alternatives? So when we look at the approach of designing a tool, leveraging additive manufacturing or DFAM, it opens up the possibilities. If you look at the design of this particular tool, a lot of the components that may have been purchased or added on are integrated into the one design. So if you look at assembly or weldment that may have multiple components, we're able to integrate or consolidate those features and design it, putting in features that provide optimized use. Integrating eyelets for storage. Positioning the triggers for the pneumatic and the suction cups very close to the grip. I don't know if you noticed it in the previous example. I don't know how long the individual's thumb or how they actually pull the trigger or execute the trigger from where the handles are. So it just makes it much easier to use. Integrating additional features to protect gauges, leveraging some existing tooling or valve bodies that may have come off the other fixtures. So it basically just gives you a lot of flexibility in how you design your tooling. So I'm going to back up a bit. So when we look at this particular design, leveraging DFAM, we have the ability also to control the internal porosity. So this is not necessarily a solid part. You have that option, but we can control the weight by hollowing or having a different infill in the body and just having solid material where we need to make attachment points. So if we have to drill and tab or put a heat stake to insert, we can add more material in those areas to give the tool the robustness. So in converting from a traditional form of manufacturing as a weldment and going to 3D printing, of course we're going to have some savings. There's going to be weight savings, there's going to be cost savings, there's going to be improved efficiencies with respect to how the tool is utilized in the operation. And sometimes the savings are significant, and sometimes the savings aren't as significant as you may think they would be. But something that's always consistent, when you have something that's on the shop floor, and you're designing and manufacturing your tooling there, you're not going through your typical purchasing process where you're designing a tool, you're outsourcing it to one of your customers, a tool and die shop, or mold maker, or a jigs and fixture maker. They quote it, you issue a purchase order, you buy it, it comes in, you go to use it, you need some slight modifications, and you start going through that process. So in this particular example, when we started looking at the savings, certainly there was cost savings of 50%, but the build time, taking something that was approximately 30 hours for complete assembly and shaving it down from a typical 4 to 6 week time frame. So having the equipment on the assembly floor makes a significant impact. And if we're looking at some of the stories of some of our customers like Honda in Alliston, when they were investigating the use of 3D printer on the assembly floor, it was very difficult for them to get justification to make an investment of roughly $30,000. The thinking within the organization was 3D printers are for product development. They're on the R&D side. They don't belong in manufacturing. And so it was a struggle to convince them to buy. And once they made that investment and they started deploying the capabilities on the plant floor, the savings were significant. They cut the lead time down dramatically. The tool's more ergonomically friendly. They reduced the workman's compensation claims significantly. And when they really tallied up all the savings, and they put a dollar amount on the time they saved as well, they had reported savings of over $800,000. So you think, well, that's a ridiculous number, but when you start adding it up, the impact is very profound. And something that they couldn't really capture, but they knew that they saw a savings. You want to see changes? Or am I doing something wrong? Sorry about that, guys. Okay, maybe this is better. So where was I? You know, something that they couldn't capture in the ROI when they reported after the first year was the improvement in employee morale. You know, everyone's looking at making things better and following a Kaizen initiative. They have a recommendations box, and the employees would put recommendations in that box, and the decision of whether to execute on that recommendation was really based on cost. How long is it going to take us to do it? How much is it going to cost? Well, let's maybe put that aside and we'll tackle it another day. But now that the changes didn't take very long, didn't cost very much, they were able to update the design and the tooling, print it overnight, and put it in play the next day. And it could be something very simple, the size of the handle. Maybe one size does not fit all. So they're able to modify the tooling to address specific end use. I know it seems like a small thing, but in the real world, the people that use these tools every day, it's very important. I like this example because it shows the creativity of people. So here's an organization that needed to develop a fixture, an inspection fixture, taking the injection molded instrument panel components and testing to ensure that their line up, that all the gaps are appropriate and things are going to fit. So instead of designing a fixture to assemble and to attach all the injection molded pieces, they had the math data of the substructure that these components were going to mount on. So they 3D printed that substructure, and then they metal plated at that substructure, and then they had the fixture that they needed to mount and do the inspection. So again, this is what we would call kind of like a surrogate part. We have the math data. Let's be creative, and so I like this example. Another big opportunity where we see 3D printing being leveraged today is end-of-arm tooling, whether it be pick and place, extraction, designing and manufacturing end effectors. And this is a great opportunity to start leveraging the design flexibility within additive. On this particular case study, the organization Genesis Robotics specialized in designing and manufacturing welding systems. And they had a project where they needed to trim excess material off a carbon fiber piece. So traditionally, they went on their way and started designing a fixture or an end-of-arm tool that attached to the robot, and using their traditional way of thinking and manufacturing, this was their first concept. So what they were doing was fixing that carbon fiber piece in a fixture and then using the robot to move around to remove the excess component. So in looking at that process, think about it. Now you have a water jet at the end of a robot that's coming in at different angles, and now you have to enclose this in a safe environment so you're not going to blast something with a water jet that you don't want to. So the thinking is, how do we change this? Instead of having the part fixed, why don't we hold the water jet fixed and then rotate that part around the water jet? So in doing so, they started going down the road of redesigning that tool. So we go from the original design down to the additive opportunities. So within the additive, you'll see that how the end-of-arm tool grabs that carbon fiber piece, and the robot rotates around, and they'll remove the excess carbon fiber. So again, in this example, they were able to do it because of the robustness of the material that they were using, the design flexibilities where they can design and have integrated vacuum lines within that tool. Because of the mechanical performance of the material, they're able to reduce the overall size and reduce the weight without sacrificing the strength and performance of that tool. So again, the savings are fairly significant, and going from a CNC machining process, which was 20 days, down to an additive process, which was a total of 3 days. So you have less weight. You can speed up that process because there's less mass that the robot has to worry about. So that extends the service cycles of your robot. And also, because of the reduced weight, you can look at maybe using a scaled down robot. The robot doesn't have to be as robust to perform the operations. Where is the computer? There it is. So in this particular slide with an image, just depicts the stages that they went through on the design process. So initially, we see this happen quite often. they'll say, well, let's implement 3D printing because everything I read in here is going to be less expensive, it's going to be quicker, it's the answer to all our problems. So, but they take a design that was designed for traditional forms of manufacturing and they start replicating it to be exact. And they're not really taking full advantage of what additive manufacturing can offer. So you can see the various transitions in the design going from traditional forms of manufacturing down through additive manufacturing. And as well, a cutaway of the design, you can see the integrated vacuum channels that we can produce. This is something that you normally wouldn't even want to consider. You may have external hoses that would allow you to transfer the vacuum. So I like this example as well because the thinking always is, yeah, 3D printing is good for small, lightweight projects. You know, we do big stuff, and 3D printing can't do it. Printers aren't big enough, they're not strong enough, we don't even want to think about it. So this really kind of dispels that theory when we look at components of what's being designed and added to the end-of-arm tooling. And the material that we see here, I'm assuming, Fadi, it's CF? Okay. Yeah. Yeah. Okay, so when they're looking at, certainly there's the weight savings, the cost savings are there, but the weight savings, again, translates into other benefits within the operation. Scale down, you can go faster, less mass to worry about at the same time, being able to go down with a smaller robot. But there's no limits, right? The limits are in your thinking and how you can best leverage. There are going to be situations where you're going to push the envelope and you'll find where those limits are. And it may not be necessarily there's a limit with the additive process of the materials. It may just mean that you have to review how it was designed. And that's where, Stratasys and JAvelin can come to the forefront and help you in that design. Say, okay, we're there, it's almost there, what do you guys recommend? And from our many years of experience, we can apply that and help you overcome those hurdles. Another way of improving efficiencies, injection molding. We want to get more parts out of that injection mold really quickly. So let's eject it early and then set up that part in a cooling fixture to cool off. So here's an example. It's a fairly large tool, very complex, but again, there's no limit as to the complexity. Quickly, cost-effectively printed, and you can see some probably just shop lot clamps and attach them on. In this particular design, we just have an aluminum plate underneath just to give it the weight, so it doesn't move around as much because it's really a lightweight fixture. Fadi kind of alluded to in his presentation how using 3D printers to just prototype or print parts. In many cases, we have the math data, and we have to start designing and developing a lot of applications or processes around that math data. So being able to print a part, which we call a surrogate part, it's a temporary part that we can use for helping accomplish many tasks. So, if you're able to have that part, you can start designing and setting up inspection fixtures. You can start proving out CNC programs. You can start setting up the assembly line or the sequence of operations as to, what is the order in which we need to install the various components. I remember one of the early projects that we were, that Magnet Closures was using 3D printing, was taking all the door components of a system and scaling it down and printing it, and using the scaled down printed models to help develop the sequence in which they're going to install the components in the door system. So everything was proven out before the manufactured components are in place. So they're not delaying, so they can get their assembly line set up well in advance, they can prove it out and validate it, and they can train all their people well in advance by having those parts. So there is significant value in having the ability to print and have a tactile part that you can use as a reference for many downstream applications. It's just a little slow. typically what would have happened in this particular case is they would probably have CNC machined some wrench shape, so they've got the kind of the Class A surface, and would maybe have done a fiberglass layup on that tool so they can get the Class A surface geometry. So what's missing though is the Class B side where all the attachment points are. So how do we get it to attach the vehicle to do some fundamental testing? So when you ask yourself questions such as, how do I handle it? How do I place it? How do I attach it? By having that data and 3D printing that part, now you have a physical part that you can verify many of the steps that you need to perform. And having the printers that have the size that enable you to build the large parts, but also do it in such a way that the parts are robust and accurate, so you're able to achieve the objectives when you print that part and you try to determine whether the part is actually going to work as intended. Some more examples of JAvelin fixtures. The upper right-hand corner is a hand-applied tool. Is anyone from AVH here today? There you go, that's one of your parts. So when you think about something such as this, some of the early models I would see there would be CNC machined out of aluminum. And so when you think about the time it takes to machine it, but most importantly, being in hand-applied, it's just the weight of that tool. So the other option is, and it's something that AVH does and does quite well, is to manufacture those leveraging a carbon fiber process. So the carbon fiber tools are lightweight, very efficient, they look really good, but they're expensive and they take time to manufacture. So the alternatives to leverage the abilities of additive and start 3D printing these tools. So you still have the accuracy that you would have with CNC machining. They also have that lightweight capability that you desire. So it's a really good solution to provide your customers. So you're not sacrificing anything, and it's something that you can deliver to your clients. When AVH and Fixture started implementing additive, the challenge with most organizations are not that you can't do it without additive. The biggest challenge is convincing your customer that the tool that was designed and manufactured with additive in mind is as good or better than what you're currently getting. So, when we talk about the savings, the time, the money, all that stuff, it's not good enough if it's just as good. Or even if it's slightly better, it's not enough to take the risk. So your customers aren't going to accept it. So the savings have to be very impactful for someone to say, I like those numbers, I want those numbers, and it's worth a shot. Because if it does work, it's huge. And we've had so many demonstrated cases that it does work, time and time and time again. So that's not something that we talk amongst ourselves and share our frustrations. When you show something that's very compelling, why don't customers or companies move to the next step? And I said, well, we're manufacturing. We're fairly conservative. We don't like to deviate from proven methods. Another thing is, as Canadians, we're very conservative and somewhat risk adverse. So when you do get an organization that has very strong manufacturing roots and they start that transition, and just like our clients today, that was probably a big step for your organization to have the confidence in additive to start switching a significant part of your business, leveraging additive. But again, taking advantage of additive, the complexity of a fixture like the bumper reach tool, you're not going to make anything like that using traditional. So it may be an option where you're using 2, possibly 3 tools to achieve the function of just that one, just because of the complexity. Go no gauge, this is from Moly Filter Systems, so they use this tool to inspect the parts that they produce. And something as simple as a headlight aiming tool. It doesn't have to be complex, doesn't have to be expensive, it just has to work. I like this case study. It's an old case study. And not that it's not as significant. But it just demonstrates that organizations were on the understanding the value of additive and implemented it a long time ago. And I think this case study is probably at least 12, 13 years old. And it's still relevant today because the challenges still exist. So being able to take something, if you look at the image in the upper right-hand corner, the traditional tool where the gentleman is holding it with his hands, that's what they were using. Because it was easy to make. It's just various stock components, cut it up, drill, tap, add the components, it's done. We have a sample of that tool on the back table. Now go back and grab that, put your hands on it, and see if you like using that all day long. Why was it done this way? Cost, time. Try to minimize it. And then you can look at something like a 3D printed option, more ergonomically friendly, lightweight, very accurate, very durable. It performs the same function, but given a choice, I would take the 3D printed model. And you can start designing and manufacturing it in a way that makes it even that much more productive. And there are some components, as much as a lot of the stuff's integrated and built in, you can still add in components that you may want to change over time. Either they may break or you may want to adjust it. You can change those components. But again, the savings are there. Time, money, and you're not really sacrificing the overall performance. And that's why people will do it, right? It's because it's better. And it's not because, hey, I'm going to 3D print it because I can and I want to and I want to do everything. No, it's a business-driven decision. As well from Fadi said, in being involved in additive for some time, and you look at our technology, specifically FDM, we're still heating a filament to a semi-viscous state, we're extruding it, we're building parts a layer at a time. That's what we were doing, or Cimetrix was doing 20 years ago, and we're still doing that today. So as much as everyone says, oh, your industry has advanced so much, it has changed so much. Yes, it has. On the mechanical side, yes, the systems are faster, more reliable, better accuracy, but the fundamental manufacturing method is still the same. What has changed our industry? What has assisted in a rapid adoption of 3D printing for manufacturing? And it gets down to materials, and Fadi kind of alluded to that. So today, available from Stratasys on the FDM side, I'm just focusing on the FDM because that's where we see the broadest adoption as far as leveraging 3D printing in an organization. And in fact, FDM enables many of our clients to cover a broader spectrum of applications when they're in their business. So when you talk about supporting the product lifecycle, FDM really does that from the conceptual stages to the advanced prototyping and field testing, to jigs, fixtures, assembly aids, potentially an end-use part, but also the in-service life. Think about doing repairs to, I'll stay within the automotive world, not in the aerospace MRO world, but there are warranty issues with cars. And these cars are already in consumers have them, they're using them, and they need to be fixed. So the OEMs have to develop specialized workflows, specialized tooling to support the repair of these vehicles at the dealer level. So in as much as the cars are designed and manufactured, they're shipped, customers buy them, they use them, the need of 3D printing doesn't die at the time that car leaves the plant. So, leveraging 3D printing to manufacture a very limited, low volume repair requirement of a warranty claim that's in the field. And that's what we're seeing the OEMs invest significantly in it as well. So I've kind of broken down the material and the general engineering and high performance. So it's very broad and based, but I'm just going to focus on the ones that we see utilized significantly. And as much as ABS is a very basic, very well-known material, it's still widely used because it gives us the robustness and the strength, and it's a low-cost option. What we're seeing certainly being adopted at a rapid rate once we introduced our FDM Nylon 12CF. It's a nylon-based material with a carbon fiber infill, and I think it's a 35% infill, so it's a very robust, strong material, very, very stiff.
It's ideal for tooling type applications where you're looking at lightweighting them. At the same time, you want to maintain the stiffness so there isn't any deflection or bending when you're using that tool. And so there's a number of samples at the table at the back that are printed in the nylon 12 CF. And some other materials that we've introduced on our F series is TPU. It's a elastomer, high performance elastomer. And where we're seeing that certainly being deployed is supporting certainly the product development side, but in many cases where we need soft touch applications, where we need flexible masking tools or alignment tools. So we're seeing TPU being utilized fairly extensively in the tooling applications as well. So within the Stratasys FDM family, we have the F series, which is an entry-level high-performance system, and the material options available there are ABS, PC-ABS, an ASA, which is a UV-resistant ABS, and TPU. We're also introducing in our F370 platform. Can I talk about the D word, the JAvelin-like material? All right. What's it? somewhere between JAvelin and UHMDW, because we look at the material that our clients are machining and using, and they're very comfortable with, right? So we don't want to say, well, you can use this material. How does it align up? How does it perform? So we take that guesswork or that apprehension away, and we develop that material and launch it. So the F-Series families are entry-level systems, and we get to the mid-level production-based systems, like the Fortis 450 and the Fortis 900 models, where you have access to every material option that's available on those platforms. So you have a lot of flexibility. But the core materials are, I think, ABS, the nylon 12 CF, and the TPU. So I'm just going to briefly talk about the nylon 12. Again, very broad application supported, super strong, has really good performance. It's available on the Fortis 380, the 450, and the F900, so a really broad selection of capabilities. But just to show where it stacks up in comparison to some of the materials. Of course, when you look at the tensile modulus in XY, because of the material and the carbon fiber, the orientation or the features built in the XY are significantly strong. So the improvement going from just the nylon 12 at 186,000 PSI, now we're well over 1 million PSI as far as the strength of that part. So you can see the significant difference. So it becomes very, very desirable. How does it kind of stack up? Traditionally, in the additive world, nylon is a very common material used in the SLS process. So many of you may be familiar with an SLS nylon part. And it kind of has a reputation of being very strong and robust. And doing a comparison of the NITEC SLS nylon 12 CF compared to the FDM, we're seeing significant improvements. Overall strength by 25%. When we look at the tensile modulus, over 100%. So you're not sacrificing. So right now, I would think that that's probably the most robust material that's available in the additive space today.
Why stiffness is so critical, that picture of being passed around for window alignment. Once those substances take hold, you don't have a stiff material, the whole thing is smooth. There's no alignment capability. So stiffness is very critical. And then the end of our tool example, where you're picking up the 15-ton part on a 3-foot tool, swinging around at full speed of the robot, you don't have the stiff material. You're going to have a diving board kind of reaction. So stiffness is very critical. That's why we want to highlight it. It really opens up the application.
This is a recently released material, the TPU 92A. Initially, when we introduced it, we certainly kind of gearing around a lot of automotive applications. So if you pop the front hood of your car and look at your engine, there's a lot of rubber kind of ducting or high performance, high heat deflection ducting that's in there. And I saw an application right away for some of our clients that are involved in automotive industry, but aftermarket. So when they're designing new turbocharging systems, new induction systems, there's usually something that connects a new revised airbox with the intake system. So they kind of designed that duct and they were 3D printing it rigid, but then what they weren't getting is how do we install it? Is it flexible enough? Can the company that's doing that upgrade in the field and install it? So for them, it was a blessing that they were able to leverage the TPU material and 3D print it and validate that they can install the upgrade. The 92, of course, kind of designates the show hardness, and I'm sure we're going to be developing more elastomer materials with different durometers on the FDM side. But where we see it also is not just in design validation, but some tooling applications, and where you need a soft touch situation. I'm going to be playing. Closing off my presentation by playing a video of Polaris, and Polaris has been a long-time customer of Stratasys and leveraging additive for quite some time, and they've and having a close working relationship, they also get access to new materials when we launch them, because we really are interested in feedback from our customers, and that feedback goes into modifying or tweaking the parameters to ensure that when we launch, release a new material, it's good right out of the gate. But we have some samples in the back of the TPU, and there's one tool that's kind of somewhat like a masking tool. It's flexible, so we can, actually that gentleman in the far table, they're going to put you on the spot. There you go, thank you for holding that up. So that's a tool that they lay on the rear fender of one of the motorcycles so they can add some additional emblems and such. So think about on these fenders that are already painted and they want to protect them. So it enables them to not just have a hand applied to set up a logo, but it's soft in nature so it doesn't affect the painted surface. Of course, you guys are involved in automotive, so you can imagine where TPU could be leveraged in the vehicles and how our organizations, our customers are leveraging that capability today. No. No, go ahead.
Listening to James talk, I know this is exceptionally done. Some of you do not have experience with additive, and I just want to reassure you from the standpoint, number one, let us help you. So one of the things I find to be extremely valuable is when we have an application engineer walk through your facility, and they can usually identify if it's a good fit for additive and what those fits are. So it's kind of that first step to say, is it viable for our organization? As I said about James and Cimetrix JAvelin, they've got more experience doing this probably than any company in the world selling additive manufacturing. And I'm not saying that that's not nonsense. It's their level of experience is incredible. Number two, DFAM, design for additive manufacturing. Again, an issue we run into with customers all the time. They buy into the concept of additive manufacturing, but they're trying to do it with traditional designs. With the merger between Cimetrix and JAvelin, now you've got an exceptionally strong organization, both from the manufacturing side as well as from the design side. So all that CAD experience, all that design experience. So you're going to have a lot of help, to start to put that right strategy moving forward. In addition to that, George and Barty's team have helped a lot of organizations as well. Some of these designs you've seen, they've actually worked hand in hand with them to actually redesign those tools. So you're not alone. You've got a lot of experience in this room that can help you kind of figure out what the right solution is. And we may not be the right solution. We'll point you in the right direction. Status quo is very easy. The traditional manufacturing is very predictable. You know what's going to happen. Right now, companies that are adopting this, they have a strategic advantage over their competitors. It's very quickly changing where it's not becoming, you're going to need it or you're going to be at a distinct disadvantage. So we're here to help you. And I just want to, I'm listening to James, and I know been in front of enough companies where I can see people start getting a little nervous about that. Like I said, we're here to help every step of the way.
Thanks, Paul. I'm sorry if I make you nervous. I don't know how many times I talk about case studies or share examples of what other organizations are doing, and anytime you're doing a presentation, it's difficult when the message that you're conveying is something that you think is important or relevant to the audience. And of course, it's much more rewarding and comfortable when you start talking about things that you're interested in talking. And that's why having time for discussion and for you to approach any one of us to talk about a potential opportunity within your organization where you think there may be a fit. Now, there are attendees here today who have adopted Additive, implemented, and are milking the capabilities every day. So for you, it's a no-brainer. You've done it. And the opportunities that exist are, what else is happening? How can we be strategic? How can we take the initiative to get ahead of that curve? I've been servicing this market for a long time, and I see, 3 categories. Certainly, there's followers, laggards, and then the leaders. And quite often, in working in the manufacturing world, the question I got asked a lot when we were showcasing capabilities is, who else is using this? Who else is using it? And so I answer it with a question. I go, why does it matter? Tell me why it matters. Are you happy if I tell you there's 100 other organizations just like yours that are using this today? Or are you happy if I told you you're the only one? I know, or I'd like to know I'm the only one. Because then you're getting a head start on everyone else. So as much as you think, if I'm going to do something in my business, for those of you who've already invested, you're well ahead of a lot of people out there. If you're thinking, if I do this, it's going to make me better. Of course it's going to make you better, but will it give you that head start? Will you getting a competitive advantage? And salesmen will say, yeah, of course. It's the best thing. But in essence, reality is you're just catching up. So how are you going to go to that next step? To add on to what Paul just said is you can buy the system. Anyone can buy the system. There's no discrimination. It's what you do with it. So what is it that you're going to do? And who you're going to partner with that has been doing it for a long time that can help you achieve your goals in an expedited way. Unless you have luxury where you can make big investments and the equipment can just sit there. And there's not an owner walking around asking, why is that machine sitting idle? Because you know that when it's sitting idle, you're not making money. So that's the difference. And it really doesn't cost you anything to go out and investigate or invite us into your business and to allow us to work with you to help you identify where there's opportunities. And as Paul said, we'll tell you where it works and tell you where it doesn't work because we want you to be successful. And that's how our business grows, quite frankly. It's a little cliche, your success is our success, but the way our organizations have grown is because we truly care about our customers and we want to make sure that they're successful. So, going back to what I said as far as, are you a follower, a laggard, or a leader? Ask yourself that question. And I'll just close off with that, and I want to play this little video. Thank you.
What is the most common high quality snowmobiles, off-road vehicles, and motorcycles? We developed our first snowmobile over 65 years ago and continue to develop new products and innovate ever since. With all the hands-on snowmobile that we do, we've begun using 3D printing to change what we think about tooling solutions for what we need to solve problems we face every day. A lot of what we do works around different style tools, so we from regular hard plastic 3D printing materials to some of the new more innovative materials. So the biggest benefit of carbon Stratasys and their technology is the ability to iterate on new tooling designs. Being able to come up with a design, test it, prove on it, and repeat so we get to a good final product. We install a lot of complex parts that adding addresses, things of that nature to our lives. Having the ability to 3D print that question out quickly and variety of materials makes a lot of flexibility. We work with a lot of chrome and paint parts and we strict cosmetic standards that we meet all of our customers. So this is where the cast materials fit so well in our hands. They're soft enough to not anti-graphite parts, but durable enough to withstand our assembly and manufacturing. So one of the more recent projects we worked on these production quality parts have taken place in a lot of leather and vacuum form parts, which are very time consuming to produce.
your advice would you incur potential costs, which technology costs, is not only cut those costs significantly, but also cuts our time for tooling, especially will allow us to stretch it into other areas we would not have previously considered to be new technology.
This has been a huge benefit to the team. Instead of waiting anywhere between 8 to 12 weeks, we're able to get designs within 24 hours. You have more iterations on the design process up front, so that you have greater confidence when you go to pick up your final tools for production. One example that we Stratasys was with the new interior component of our vehicle. It allowed us to see overall integration into the interior faster. Actually, the parts to test things out goes a long way. Sometimes you don't really see a lot of different benefits. So being able to see the part in real life and test different scenarios and make sure that it fits into the new interior is a huge benefit for us.
We've been working with Stratasys for over 20 years, and our partnership with Stratasys allows us to have robust engineering capabilities in-house, which reduces their lead time and lowers the cost. Working with Stratasys has helped us open our minds to what's possible with very complex problems and geometries, good solutions that enable productivity, quality, and speed of our manufacturing process. The quality of Stratasys equipment gives us the confidence that we're doing a good part for the first time every time. The early exposure to new materials is very helpful. So being on the front line of the last one too, getting tried out and using production early is super helpful.
It's really well on horizon on what we can do with 3D printing, applications we would not have previously considered.
We're actually really excited about the future of that manufacturing, and we look forward to continuing partnership with Stratasys.
It's a really good example of how an organization has adopted additive for some time now and are deploying it right across the organization and certainly taking advantage of the new materials that we develop and launch out there. Before we break for our lunch, we fortunate enough we have 10 to 15 minutes, and it's a great opportunity to ask any questions regarding what was presented as well as anything else that comes top of your mind. Yes. So it varies.
James can
thanks for explaining. Yeah, my question was that the applications that you explained here, maybe you can just touch upon how design cycle lasted in those from the concept of the idea until manufacturing.
Initially, it takes a little bit longer because they're not familiar with the flexibility that additive gives you. So habitually, you start designing it thinking about how you would traditionally manufacture it. And quite often, when we recognize there's opportunities, we find that our clients that we're working with, they're very busy, and their designers don't know anything about DFAM. So initially, we volunteer our services, and we work very closely with them to really shortcut that product development process. So we're guiding you along the way. And in some instances, we take on some of that burden initially just to expedite their due diligence to help come to a conclusion so they can decide whether to move forward or not. So having an extensive team with a lot of experience helps shorten that cycle. And by working very closely together and providing guidance, not only do we help you design it, but we're also giving you the guidance and advice based on your tooling as to how to design. So it's interesting. And what I see for a lot of our designers is it's almost like the handcuffs have come off. It doesn't matter anymore, right? You can design for optimization of that process versus designing for manufacturability. And you don't worry about how complex that part comes, right? Because there's no price penalty to complexity. Using traditional forms of manufacturing, the more complex that design typically means the dollar sign gets a little bit bigger. Not so with additive. So it's a fairly enlightening experience, and when they see what they can do, they're just motivated to continue doing more. We have some of our clients right now that have well over 150 parts catalog that they manufacture as end-use production parts and tooling. Like if we look at the GM plant in Oshawa, They've had their system there now roughly about a year and a half now. There's over 140 tools that are on the assembly line. And once the designers get the hang of it, it's like the floodgates are open, and it doesn't take very much to get them going. So I don't know if I've answered your question, but it's typically a little shorter. And what happens is...
Good afternoon. So my name is Stefan Boucher. I'm Vice President of Operations for Global Vehicle Systems, and actually I recently acquired a subsidiary, JC Tool and Die. So John and the group asked me to, so we're a machine builder. I'll kind of get into some details of what we do. But John and the group asked me to kind of share our experience using FDM in our process. So Global Vehicle Systems, we design and build custom automated equipment for automotive parts manufacturers with specific experience in plastic engine components, interior-exterior trim assemblies, and fuel tanks. Our customers are automotive Tier 1 and Tier 2 parts manufacturers. I understand there's a group from Magna in the room, so we consider Magna part of our customer base. With specific experience in plastic joining technologies. For the last 20 years, we've gained a host of experiences in heat staking, infrared welding, hot click welding, and ultrasonic welding. Customer service locations. So over the last 20 years, we've delivered equipment all over Canada, the US, and Mexico. So in the summer of 2016, about 3 years ago, Global Vehicle Systems, we were considered growth mode, needed to invest in some capital, and at the time the options were obviously some new CNC equipment and 3D printing. And I always tell the story, at the time that we made the final decision to purchase the Fortis 450, if I had pulled the room of our engineering and manufacturing team, they all would have voted CNC. But we consider ourselves innovators in the industry and kind of took a leap of faith. At the time, the only thing we could put our finger on to say that anything we currently machine out of plastic will print out of plastic. Not sure exactly how much that quantified or how much that made up of our total product. But we took that leap, and today I can tell you I don't know how we would run our business without it. It continues to be our employee of the month. It's run in tens of thousands of hours, since December of 2016. Currently booked for the next 6 weeks, and in peak times we've actually had to outsource our manufacturing. So some of the applications, some of the obvious applications that we use the 3D printing for are rapid prototyping, concept modeling, proof of concept, research and development of some of the products that I won't go into too much detail. You've seen some of the examples that were provided this morning. Test parts for product functionality. So part fixturing. So part fixturing, again, assembly aids, CMM fixturing in process gauges. Very easy to make, but again, we're really just touching the surfaces of what we use the product for. Again, you've seen all kinds of those examples this morning. There we go. So assembly aids, what you see over there is actually part fixturing for the manufacture of cell phone cases, using some all-temp material. This is primarily what the use is for our product today. You can see all of the black printed parts are all 3D printed. And we're actually using that to nest the parts as we manufacture our equipment. What's critical in our industry is that the plastic parts we process are fixtured accurately. This has allowed us, and you can kind of see the various shapes and sizes, but it's removed the limitations of manufacturing. Some of these components you probably wouldn't even be able to machine today, but allows us to use all the foresight features of a part to accurately and repeatedly nest the parts that our customers are using. This is actually a sonic welder for a magnet division. Now, we've also adapted 3D printing for our manufacturing support. The one that's currently been mentioned is off-tool parts. So off-tool parts are not always available through the design and the build process of our equipment. This allows us to debug, test, and confirm that the equipment will satisfy the need. Shortens up the overall lead time for our customers in our build sequence. And the other one is creation of layup molds, machining fixtures, setup gauges that our employees can use to build the equipment. So what you see here is a 3D model of what's a poured urethane nest. This is something that touches the A side of a painted part. Now what we've done is, the next two slides is actually the process of molding that urethane nest block. That's right. So what we've actually done is use 3D printed pieces to make core outs of our poured urethane nest. Typically, that entire space would have been machined out. Obviously, extended labor time, wasted material. So we're actually using 3D printed processes in our existing manufacturing. Again, time savings. So reduce cost. Through the evaluation period, when we were dealing with the team at what was then JAvelin or Cimetrix today, was cost justification. And we approach it, we still approach it from a traditional manufacturing process where how much does it cost me to print a block and how much does it cost me to CNC machine a block. Where we have seen the biggest benefit is that reduced labor time. So we design, a typical project for us may be 20 weeks. Typical time spent in design and engineering would be 10. We're able to start that manufacturing process before the design is complete. You don't need a detailed print. All you need is a 3D model, and it's direct to manufacturing. So really that in itself, which was really unquantifiable to us at the time, is where we see the biggest bang, or the biggest benefit to printing or additive manufacturing. What I would suggest is it didn't reduce cost on a project by project basis. What it did was increase our capacity. So we've actually been able to increase our overall throughput volume with the same amount of labor. And again, reduce lead time, allowing quicker design process, quicker trials, unattended hours. Our print times typically, the tables on the 450 would be anywhere from 24 to 96 hours of print time, again unattended. And then printing in those early phases of design, that critical piece to our process, the nesting, the fixturing of the part, we're able to test much sooner than historically. Now, the biggest benefit that we've seen is that removal of constraints from conventional manufacturing. There's been discussion this morning. The design for manufacturing is really where where our automotive space lives. What printing has allowed us to do is design for additive manufacturing. There are things that we print today that we would never have concepted 10 years ago. It was impossible to machine undercuts, die lock conditions. There is little to any thought or given to that in that design phase. That design for manufacturing, that's really the biggest challenge I see for us as an organization and the additive manufacturing in our space is removing those barriers. The example of the end of arm tool is exactly that. If you the first attempt at making that end of arm tool from its original design was to just print it the way it looks when you machined it. And really that change in mindset is what the Cimetrix team can help with. They've helped us do that. So I'll just take you through some examples. Freedom of design, things that we would have never done. On the top picture is a part nest. It's actually a routing or a milling, degating piece of equipment. And that tube that you see is actually the vacuum extraction. So typically in our process, that vacuum would have been as close to the routing or the milling operation as possible. So that mill actually comes straight through the nest, and we're pulling it at the point of cut, reducing debris and really saving our customer rework. At the bottom, that's actually a hand tool. Putting in a rubber grommet into a plastic pallet. Again, to be able to manufacture that and make it usable for an operator. This was a piece that a customer came to us on a Monday with a problem, and by Thursday morning they had a solution. Really was just create the profile and print it. Electrical connectors. So we're now a lot of our vehicle components obviously run electrical devices. So we actually print the component. We take the 3D map model of the component it's connected to and reverse it. Or the actual connection point in the vehicle and create that. Gives us stable and obviously replacement parts are easy to come by. This is a tape dispensing piece of equipment. What you see there is a self-centering roller. This is applying open cell tape to a door cover. This tool that you see here, I don't know that we could have manufactured without additive manufacturing. Tape guides, and that's something that you can imagine if anybody who's got CNC equipment on their shop floor, if you tried to make this, aside from the expense and the weight and the development time, it was 2 or 3 iterations to get it right, but we're talking of weeks versus months. And this is a perfect example, sensor card. I can assure you that we wouldn't machine this, and if we did, our customer wouldn't want to pay for it. This is where we're just kind of touching the early stages of design freedom. It doesn't have to look and feel like it did 5 years ago or yesterday. What's the function? What's the end goal? And then what does it look like around it? So again, a small piece to the puzzle, but really allows our design team and our engineering team to create a solution that works best for the application, not necessarily what we can actually make. So that's really all I have today. I don't want to bore you with too many examples, but I'm happy to take any questions that anybody has. So that's we're currently under evaluation with the team at Stratasys and Cimetrix on doing exactly that. We're evaluating the TPU using the FDM, and also some material using the object printing. The other thing we're looking at is can we 3D print? So when we're pouring urethane, you can see we create a mold. So how do we create that mold using FDM printing? It allows for duplication, fairly easy. The example I showed on the screen is still a urethane cast piece that we end up machining. And that the reason is, most of what we do, we're only ever going to build one. So it's time-consuming and expensive to build a mold to make one piece. But you can 3D print it. We've got some trials to 3D print using simply support material and pouring around it, and ideally some additive manufacturing way to print the finished product.
On a weld fixture, if you're creating a nest and you want to do some kind of sonic weld afterwards, do you see any functionality difference between a machine nest versus what you end up with?
From a functionality perspective, so we have not tried sonic welding on an additive manufacturer yet. Although we have done other types of welding, IR and hot plate specifically. We were backing those products up with nylon and proven materials in the industry. And really, that's kind of the next step is that sonic welding.
So what arguments did you use to convince your customer that this was the right way to go?
Just a promise that we'd stand behind it and replace it if it needed. Obviously, we underwent some extensive testing early on to confirm that it would work. But the adoption in the automotive world, as much as we like to think we advance remove the needle, adoption is always the biggest struggle. And much like we took a leap of faith and purchased that FDM printer 3 years ago, we kind of look to our customers and say we're asking you to take this leap with us. And in the end, what we believe is what we can get to is a shorter overall cycle time, or simultaneous engineering. You're still developing the product while we're building the equipment.
It's equally difficult internally to say sure.
Well, let me know if I can help.
Any more questions?
Thank you.
What Stefan said, I think you commonly see that the company brings additive manufacturing into their organization for a specific application. If you circle back 3 months later, they found so many different applications that they kind of forgot about that original one. So it's very common. Number two, I think it's interesting. A lot of us in here from the Stratasys, JAvelin, Cimetrix side come from a CAD background. And we were involved with that kind of 2D to 3D transformation that happened a long time ago. And at that time, you really freed up the design of the engineers. And then you had that whole push when you went to 3D to design for manufacturing. So now we're kind of reversing that for additive manufacturing. We can really unleash the power of a designer. So pretty cool stuff.
So I'm Bob Heath, additive manufacturing applications engineer with Eckhart. Eckhart has been in business for over 60 years, and we primarily started out in the automotive space in the assembly environment. We do a lot of general tooling, assembly environment tooling. We also have an AGV division. We have collaborative robotics. We do a lot of the industry 4.0 stuff. But primarily, I'm going to talk about the additive in this extremely lengthy PowerPoint that I've got for you today. Okay, this is my last slide. So what did we do with additive? We started out with the nesting blocks, what we call or what we call the nesting blocks, the part interface. We don't want to machine that complex geometry, so we started printing it. So that's really where it kind of started in Eckhart, is with the nesting blocks. We started printing these blocks. We started looking at, and that's when we started looking at other applications. We found that the materials were durable, so we moved on to doing some hand tools. I actually brought an example one. This is one of our most famous hand tools we have. This is a Lug Nut Starter Tool. So what this does is this resides in automotive assembly as well as industrial assembly plants. So we have different versions, obviously, but the operator basically puts a lug nut in each one of these, puts it up to the vehicle, spins the outside, and it starts all those lug nuts right at once. So it's something that we couldn't manufacture traditionally. We were able to manufacture it with 3D printing. We've done other examples of our hand tools have been windshield wiper fixtures. We have a lot in several automotive factories. That fixture is a lot harder to see than I thought it was going to be, but it's a single piece tool. It positions the brake pedal in an automotive factory. And then after hand tools, we started doing some end of arm tooling with the robotics, and you guys have seen some examples of that today. So what we've been able to do is increase cycle times, which you've seen. One application where we had where we installed a robot with the end of arm tool is a side benefit of that robot was the quality of the part was increasing because it was the molding process, the way that it was going before, the cycle time, the mold was cooling down too much, so they saw an increase in the cycle time, or decrease in the cycle time, however. But with the mold not cooling down as much, the quality of the part was increased. We also have done design studies where I've gone into a manufacturing facility and looked at an application and said, maybe we can solve this challenge with 3D printing. So that's where I'll go in and out of the factory with trial parts, and that's also, one of the fastest ways to find the exit in the manufacturing facility is say, here, try this. So, we will, can we do something with 3D printing? We gladly investigate that for you and give you a detailed report on the feasibility of that. And in hand with that is we do a lot of workshops with our customers. We'll go into the facility, we'll walk up and down the line with plant personnel, talking to operators, talking to the people that are ultimately using these tools, and trying to figure out what are the pain points, what was wrong with that quarter glass fixture that you saw earlier, how can we fix that for you, and how can we improve upon what you already have, or we may notice something and say, that person over there, what they're doing, if they had this, that would probably make their life a lot easier. And they say, yeah, that would make their life easier. But we can't justify that cost. We can't justify that expense for that simple thing. And when we investigate it further with 3D printing, we find that a lot of times they can justify that minimal cost. And then the latest thing that I've been doing, working with one of the OEMs, is to do a lift assist, where what we're doing is we're picking up an aluminum transmission housing coming out of the machining center, picking it up, putting it into dunnage. This lift assist is completely 3D printed. We're using the nylon 12 with carbon fiber. The housing weighs approximately 25 pounds, so it's not a huge weight. But what it's doing is it's in similar vein to that quarter glass fixture, is it's replacing a giant, bulky, hard to use tool with a much simpler and lightweight tool for the operator to use that solves all of the problems, and some of the problems that weren't even readily apparent to the situation, such as the operator, the fatigue, the morale of the line workers. You know, so there's a lot of that. I do have one other example that I brought that goes hand in hand with what we're talking about with the design for additive manufacturing. This is a sensor guard for our AGV. It's a prototype right now, but this is it consolidates 3 parts into one. It reduces a lot of cost, and it's so those are the 2 big things. But this is what an example of something that, you know, there's features on here that we may not want to machine. We might not have thought about how to design it. And my thought process in designing this part was, I need to hold my sensor here, and I have to have adjustability. And then I got to mount to my other bracket here. And so all the other features are left to me and my creativity. And what we can do and what the machine can do. And so being creative, we can also, you know, we don't have to have what's the word I'm looking for here? We don't have to follow a prescribed process. You know, I can take material out where I want to, and I can, you know, make it so that it's a better overall product. Is what I'm trying to get at. Not really good at public speaking, but I'll pass this around too. If you guys haven't noticed. So that's pretty much my presentation. Is there any questions right now? Yes.
What design software are you using to give you that freedom? Are you into 3D generative design?
A little bit. I've used that mostly. The default design package we use is SolidWorks. I have experimented a little bit with the topology optimization, and I'm doing some cursory investigation into live parts as well.
I got a question. So, I don't think
So we've been working with your organization for the last couple of years, and we know your CEO, Andy Storm, really well. In fact, if you ever want to look at a video where someone really speaks eloquently about additive, just on YouTube look up Eckhart Stratasys. And what strikes me about their organization, and maybe you can comment on this, but it looks to me, and we've worked on a number of things together, that really Eckhart's mission, and I've heard Andy call it Industry 4.0, you guys are driving innovation in a lot of different areas in manufacturing, and what it looks like to me is you're using additive to enable a lot of these innovations and bringing a lot of these high-tech solutions to your customers. Would you say additive is a strategic part of Eckhart's plan going forward as you guys drive Industry 4.0 in your customers?
Yes.
Can you elaborate on that? I probably did too much framing of the question. I cut my own throat.
Yeah, you answered your own question. I'm just agreeing with you here. You know, we're using additive to help with Industry 4.0 to advance some of the, you know, the collaborative robots. We're using the additive as an end effector or an end of arm tool. We're using additive with our AGVs. We're using it for prototyping. I don't want to say everything, but a lot of the advancements that we've been able to make internally are because of additive manufacturing and 3D printing. We are also able to broaden our suite of solutions because of additive manufacturing. Does that work for you?
That's what I was looking for.
Okay.
How much of your business would you say has been
transformed by additive manufacturing, or how does it affect your bottom line in terms of percentage-wise? Or is that hard to quantify?
So we've been doing this for a couple of years. So we have a limited or small data set on a return. What I do is I support all of our Eckhart sites. We have multiple locations each with their own customer base. In Southeast Michigan, we primarily deal a lot with automotive. We have in Iowa, we have a customer for what the industrial agricultural space, John Deere, Caterpillar. In Minneapolis, we have a robotics or a dedicated robotics team. So me working with all of those has allowed some of the tools that they would traditionally manufacture that were hand tools that were made out of aluminum, that were the pieces were water jetted or lasered and then welded together and cut down, or through additive we've been able to cut down that lead time as well as taking out some of the cost. One thing I'm working on is, we don't want to take what you previously designed and shove it through a printer because that's not good. That's not what we want to do. We want to take advantage of what the printer has to offer, just like we would take advantage of what a CNC has to offer. So each process has its advantages and disadvantages. So it's been a couple of year learning process for me as well as our sites. So a lot of education in there. And we are seeing some cost reduction, but the biggest one that we're seeing is the lead time reduction and being able to turn parts around because we can run the printers, overnight, over the weekend.
All right, I got a super quick question. Can you talk about the workshops a little bit? What they look like and who can attend?
Yeah, so the workshops would be, it's typically Andy and myself will come to your facility. We look for, not only some senior leadership, but also the day-to-day operators and people on the assembly line or the machine builders. We want to get a broad range of people that are in the company involved in this. So we do a quick, and then the day or half day, we kind of schedule it out so that the morning, we do a quick presentation on who we are. We introduce ourselves. We say additive manufacturing is really cool. And then we break up into teams and walk out to the facility and look at how things are being done, how you're doing things today. And in those groups, we brainstorm. And we'll come back, have lunch, let those ideas digest in your head for a minute. I'm usually the person that's like, I don't have any questions right now. But a half hour down the road when I'm almost done, I'm like, I should ask them this. Well, what about that? So we try to let those ideas and that what we did in the morning kind of digest and rattle around in the brain for a little bit, and then in the afternoon we start listing out the ideas and say, all right, and that's where we kind of see more ideas being generated because somebody would say, well, what about this? Somebody else would say, I didn't see that, but this is like that. And so we get all those, we compile a list, and then we start prioritizing them, and then us Eckhart, we own that list, and then we work with you to prioritize what do you want to tackle first, and we go through the list and provide those solutions. So.
Thanks, Bob. Great job. I think that's another great point that Bob just brought up. Whether you're doing it internally with your own team, or if you bring in someone like Eckhart with Bob to come in and kind of do a walkthrough on your own once you've got the technology, I think those brainstorming sessions lead to tons and tons of great ideas as to how you can actually push the technology to the limit. So great point. And again, I think one of the things he's talking about design freedom. Stuff that you can't traditionally do that you're restricted with this type of technology can really accelerate it. All right, up next we got Jay from Ford, and we're going to turn it over.
My name is JAvelin. I'm the additive manufacturing engineering supervisor at Ford. So Ford opened up an advanced manufacturing group. Additive manufacturing is a portion of that. We also have some
other Industry 4.0 initiatives going on in advanced manufacturing. So our mission, the goal when we were formed was really to get more additive manufacturing into our manufacturing operations. So in line with what everybody else has been telling you, jigs and fixtures is a good area to do that. We also have some production aids, some wear items, wear being consumables, things that wear out. We were able to print them out of a plastic, and we actually replace them more often, but the cost is so much less that it ends up being a positive for us. We're assisting the plants in getting printers, recommendations on what to buy, and helping them get started. Spare parts are going to come along when groups like Eckhart design their tools with additive parts, so then we can print them on site as needed. So that's an evolution that's still in process. And then tool tryout parts. We do a lot of prototyping in our shop already, but even just recently we printed out for a new model coming up a whole door and a door glass because they couldn't figure out whether we could really load the glass on CAD. So they wanted a physical piece and see if they could come up with a technique for loading the rear door glass. So that was a big cost avoidance in getting down the road until it's too late, and then all of a sudden you got a big problem to fix. The other half of what we're doing is we're preparing to additively manufacture parts that go on vehicles. Part of that is define and redefine our PPAP process for additive manufacturing, capacity planning, seeing what machines are out there, how fast they can build, how many we're going to need to produce the volumes we're trying to make, and see if the business case is there. And we're also working on automating some systems. So we're going to have some AGV robots that will load and unload one of our SLS printers. That's an ongoing project. Just real quick, and we have about 30 printers in our building, and they range from the vat polymerization to material extrusion, material jetting, binder jetting, outer bed fusion, and sheet lamination. Just about covered the gamut. The area where we don't have anything yet are like the EVAN and deposition, metal deposition we don't have yet. So we're still working on that. So, as you all may know, post-processing is the great unspoken of within additive manufacturing. So this is a plate of metal parts that were done, and when this is done, you got to pull it out and get all the powder out, and then you got to cut those off the plate and cut off all the support material. That's a lot of time and labor, especially with metal. And you gotta, if you're doing aluminum, you really gotta make sure you got the powder off, because aluminum powder is a bit flammable. So efforts. One of the things we really like about the Stratasys FDM stuff is the dissolvable support. So we finish the print, we throw it in the wash tank, we come back a couple hours later, and our supports are gone. We don't have to spend a lot of time on it. Next. Design for additive. I'm going to go through this real quick. There's software is coming a long way. It's evolving quite fast right now. We use, for the question earlier on the optimization, for 3D CAD, we use SolidWorks, we use CATIA, we use Inventor for optimization. In our group, we've typically used Altair or LineParts, but all of those softwares are changing and improving
it seems like daily, but I mean, it's every few months. But there's a lot going on there. Our team in Europe, here's a good example, designed for additive. They took this is all welded together with tube steel and reduced the weight to like a tenth of what it was, and still are able to locate brackets with that fixture. Okay, so I'm going to just run through a whole bunch of different examples of what we've done and what we're doing. Body construction, we actually have some blind holes, so there's several layers of sheet metal. We have a robot that comes in to drill a screw through, and they need to hit that hole in the middle sheet so it clamps all the sheets together. We were having troubles finding it, so we printed up a template to show the operators where they were. They're able to teach the robots to those spots that they shoe in away. Here is what we call a plug gauge. So that's call it a nominal headlight. So they stick it in and they make sure all their fit and finishes are valuable. What's nice, those used to be machine built in aluminum. They end up weighing 20 pounds. So you put them in and the weight was so much it deflect the whole rear. And it wasn't a good example, it wasn't a good test. So we're able to tune these to actually be the actual weight of the headlight or tail lamp or whatever the case may be. Obviously, just profile blocks, we can take measurements on flush and margins. Here's a recent one of our vendors did. They're starting to print out clamps for sheet metal and the robots. And you can see the red part here, that's an overmold. So they printed out a mold to fit the profile of the sheet metal they're clamping to, and molded that and then attached it to the clamp. So no complex machining anymore with that. This is we call it a fascia simulator. So when they're setting the hood in the body shop, there's no fascia on it to line up the hood to. So one of our engineers had this idea to just print out a section of the fascia that attaches to the front end. So we have something to line up the hood to when they're setting the hinges in the body shop. In final assembly, we've sky's the limit. Here's a VIN stamp. We stamped the VIN number on the transmission case and the engines, and then also in the body in a couple locations. So we have to match the profile of the casting there with the VIN stamp machine. Badge templates, windshield wiper setting, some other small sub-assembly fixtures. Actually, one of the floor engineers designed those up and we printed them out and haven't had an issue with them. This is out of the TPU material. It tells the operator where to put a clear mylar patch for stone chip protection. But we built it out of the TPU so we didn't have to worry about scratching the paint. And these were some environments. We do an assembly of the vehicles on CAD ahead of time, and there's sometimes you just can't tell whether there's going to be an issue or not. This was a hand clearance issue with hooking up the shifter cable on an F-150. So we printed out the environment that the operator was going to have to try and make that connection in and checked to make sure that they can do it safely. And then steering wheels for clear vision. When you set your alignment, you want your steering wheel to be at 12 o'clock when you're going straight. So we print these out a few months early so they can develop the tooling to fit in the steering wheel. There's some interesting examples here. So some of these came from our plant, our Kentucky truck plant. So all our conveyors run on these electric motors, and they have encoders to tell them how fast they're going, how many revolutions they're taking and such. Well, when an encoder goes, they shut the line down. If the line's not running, you're losing money. So one of the guys there came up with a little quick fix kit. And the red part is printed, and it just snaps into the vent holes in the back of the thing, and then they have a shaft extender, and they have an external encoder that they can put that on in 10 minutes or less and get the line back running, and then wait for a break to go in and actually pull the normal encoder and see what the real problem is. So there's a huge money saved there just in keeping the line running. This was another one they did. Not that I would have encouraged it, but this is a linear bearing, and it went bad on them, and they didn't have any in stores, so they printed one up and went through 2 shifts until they could overnight a new one on site, and were able to run for a couple of shifts on the printed bearing. We have socket sleeves on all our rotating tools for safety. We print those up. We got paint templates for wheels. Here's one Stratasys printed up for us, tube bracket. We're going to probably redesign that. They use these on end effectors a lot, so you aluminum tubing and clamp together to set up your frame for your end effector on your robots. Those are usually aluminum machine billet, and they're expensive. We'll see if that you saw that already. You're taking it. I've seen it enough. So stamping, die lifters. They're doing a similar thing where we're printing out the profile that they have to lift and pouring urethane in there to match the profile so that our die lifters aren't damaging any machine metal as they go through. These are, we call them shovels, but they basically carry the stamp part from die to intermediate fixture to die. And then just tool holders, whatever you can think of. Finally, this is a current project going on. So we call this a C-rail. And it's a lift assist, so here it's picking up HVAC plenum for the Ranger. And the operator sticks it in. And it's a big seat because you got to wrap around the in the vehicle. So we used live parts, and you can kind of see it in a faded green here. We designed using the topology optimization and loading the part that we printed up. So we printed it up like this. We pull tested it. We realized that we're at a factor of safety about 10 to 12. So we've got a lot of room to trim this up a little bit. We're being pretty conservative. So we're going to go back and take a few more pounds out of that fixture and then take it to the assembly line and see how it goes with the operator. But we think we can get it lighter than the steel tubing. This is a pretty efficient tool already, so this was a high mark to start with. But we think we can get it lighter than that for sure. Cost-wise, that's going to be a struggle, but we're going to take a shot at it and see if we can start doing more fixtures like this for cheaper and certainly lighter, help the operators out. I think that's the last slide. Any questions about any of those things? All right.
Nobody has any questions for the Ford Motor Company using Additive? I do. So Jay, what were you doing, and we're going to have a panel discussion here in a minute, so what were you doing at Ford before you got into this whole additive thing? And what has that transition been like, going from what you were doing before to what you're doing now in the additive world?
So I was an automation engineer. I did a lot of glass cells, so the robots that will put the urethane around the windshield or back window, and they also robots that are back into the vehicle. Most of our windshields and backlights are vision guided decking. So I was doing that and launching from playing around the road all the time. So this has been great because I get to go home every night. But it's been a big learning curve. what's going on in the industry, but I got a pretty good taste of it from our standpoint. And it's been a great transition. I really like the additive world.
Okay, great. Any other?
How do you evaluate what projects are appropriate for additive manufacturing? Is that assigned to you, or do you have a team that goes around and looks for efficiencies?
We're a little bit everything. So we have a team that's assigned to get additive out there and in front of people, so people start thinking about it. At the beginning, it was a lot of going out and fishing for projects, talking to plants, and trying to find applications we could show them what we could do. In the last 6 months, I think we've switched the tables where they're calling us, saying, "Hey, we've got this tool where this problem. Can you guys take a look at it and see what we can do?" So, not a whole lot of going out and looking for work. It's kind of coming to the
Any other questions?
Are you also exploring actually manufacturing parts in higher numbers compared to just, not just, but compared to the tooling and fixtures environment?
Right. So we have 2 parts right now that are actually going on vehicles. We have a delete plug for some switches on the Raptor that gets exported to China. So it's only about 500 pieces a year, but it went through the whole feedback process and testing and evaluation. And has a Class A surface on it too, so that's something for additive to do. That's done on our carbon machines. Also on our carbon machines, we're building a bracket for a brake line, the GC500, and that ended up being, we were able to redesign it so it was symmetric, so it was going to be a right-hand, left-hand part. We have a single part now. It's, I want to say, 70% lighter than what it was as a stamped sheet metal, which was the original plan, and we're building 16,000 of those a year. So we're there, and we've got a lot of other projects looking. We talk a lot with Ford Performance because they tend to have the low volume stuff. We're having a lot more conversations with Lincoln on their branding and what they can do additively to customize vehicles. So that's kind of where I think everything's going to start with some of those smaller volume programs. See where it goes from there.
So still, what's the sweet spot regarding considering a small part like you said, lining out of a switch or something? What's the sweet spot right now for how many thousands a year would you consider?
So that's everyone has to go through its own business case because you're gonna compare tooling costs and a piece price with whatever the part is traditionally versus additive. So additive oftentimes per piece is more expensive when comparing it to traditional manufacturing, but you can avoid the big tooling cost. And then you can change the design every year and not have to redo that tooling cost if you want to do an upgrade. So there's definitely some advantages, even at a little bit higher piece cost to stay with that.
Any more questions? We're going to put him right back up there for the panel, so take something. Thanks, Jason.
The skepticism that you encountered, everybody wanted to invest in another machine tool and not necessarily do 3D printing solution. In retrospect, in the 2 years that you've been running, what a lot of our customers ask us, have you guys been compiling any kind of statistics on the financial success of the machine, how much cost you've saved, how much time you've saved, how the quality of things have improved? Have you guys been working on ways to document that?
So the short answer is no.
Okay, next question.
It really comes down to those unquantifiable pieces. I can tell you it's actually changed our manufacturing strategy overall. Industry 4.0 is not something new to the room, but really it's changing the way we traditionally manufacture anything, changing the way we design it, changing the way we approach it, changing the way our engineers think about manufacturing. So it's really hard to say. I kind of use the example that it takes 12 hours to CNC machine something and it takes 25 hours to print it. You touched on it from a material perspective or a cost perspective. It's probably a little more in the additive manufacturing world. But what time did it save you in the overall timeline? How much faster did you respond to your customer? What was their downtime? And really what the biggest impact we've seen is our ability to throughput more or less.
So you'd say time is one of the biggest.
Absolutely, and I'm sure all dealing in the automotive industry, time outweighs cost for the most part. If you can do it faster, then cost is less of a factor.
So qualitative though, do you think your executives and the managers in your organization have recognized and are happy that they made the investment in additive those 3 years ago?
Absolutely. Since that time, like I said, when we purchased it, we thought, well, we'll just print whatever we machine out of plastic. Today, we wouldn't be able to run our business without it. We've outsourced 3D printing. We're currently evaluating, obviously, additional capacity in that sector, and as well as metal 3D printing. If we could figure out how, if metal 3D printing was as stable as current FDM processes, that's probably what we'd be doing today.
Is it safe to say to the folks in the audience that your decision to buy additive got you promoted in the company, and if they decide to buy additive, they're going to get promoted too?
That's right, absolutely. Yeah. For a small price, you can have mine.
Okay. I have a question for you, Jay, and then we'll throw it open again because I don't want to ask all the questions. But one of the things that we talked about at the beginning was the difference between having machines in the plants versus just having an internal service bureau that prints everything from the plants. Can you comment on how having printers in the plants maybe has given the organization a little more understanding, like at a plant level, what additive can do for them?
Sure, and honestly, they found a lot of applications we never would have thought of.
Yeah, I saw some detector truck stuff up there.
Yeah, the tough part's finding the people that want to, not that just want to run it, but also do the 3D modeling and learn the software to slice and all that. So if you've got that kind of talent on site, shoot, the sky's the limit. You'll find all kinds of stuff you never dreamed of. So having stuff at the plants has been a big help for us. I was just on the phone with people from Chicago last night, and they've got an emergency, but they've got a couple printers right there, so we're sending files over there to their printers so they can take care of this issue. So that's also been a nice benefit. We can, if they don't have the time or the talent at the moment, we can throw some resources at developing the design and build file and just send it over to them.
Great. So I got a question for James. Oh, did you have a comment on that?
We've seen it firsthand with the JAvelin plant in Oshawa. When they're looking to develop a tool that they're going to use on the line, they ask for feedback of the individuals that are going to use it. And so being there, they can print the tool, they can use it, and make some adjustments. That iterative cycle is so quick. So the same day or the very next day, they can get an improving tool right on the floor. And that goes back to time. Time is of the essence all the time. So imagine if you wanted to make a change, now you got to communicate that change to another office, maybe in another country. You have to communicate to the designer what he needs to change. You may go through 2 or 3 different iterations before you're on the same page. And that will kill you. Any of the gains that you hope to gain by implementing additive are just thrown out the window. So time is of the essence. We see big impacts with the capabilities on the plant floor. If you have to go to a common service bureau, you might as well go to another service bureau. You're not really achieving any of the gains. Where are you in the priority queue? So you tend to suffer in those cases from what I've seen.
You have a comment on that? Okay. Well, and this is something that we've been working with for a long time. As companies grew up with additive, because mostly all they were doing was making prototypes, i.e., there's the design on the screen, print me a 3D printed version of it. Where the printer was pretty much immaterial. It could be anywhere. Because really no design changes were being made. You were just printing what the designer asked you to print. On the manufacturing side, though, the people in the plants have the knowledge of what their manufacturing processes are. And what we say a lot of times, it's a lot easier teaching a manufacturing person about additive than teaching a 3D printing expert in prototype about manufacturing. I mean, they don't know anything about manufacturing. One of the guys from General Motors told me one time, he goes, he was in the model shop where they do the prototypes. He goes, George, I've never even been in a plant. They're noisy, they're smelly, and they're dangerous. Why would I ever want to go there? So, anecdotally, the shift of additive towards the manufacturing side, we think has been facilitated greatly by getting the capability of the machines close to the manufacturing people. And we've seen a lot of synergies from that. All right, so I've asked 3 questions. Can the group help me out with 1? Anything over there from Magna?
I'm curious about the hub and spoke model that keeps being brought up. If you had to do it over again, would it be a spoke versus a hub? Which is the biggest, if you talk about which is the more valuable? Because I can see the same dynamic happening with my.
I think you're asking, who you asking, Jay or?
I guess Jay.
That's a good question. I definitely believe printers in the plants is a good idea. I like the hub and spoke just because we have a lot of SLS, we have some SLM printers. I don't think we want to put those in the plants yet. I think they're a bit of a maintenance nightmare as far as keeping things clean and such. So I think there's a place for each, and center of excellence or whatever you want to call it. For some of the more advanced printers, it is appropriate. And then getting the FDMs and some of the simpler stuff onto the plants it's also valuable. So I don't know how else I would do it, honestly. I think it's worked well for us.
I think the center of expertise certainly makes a lot of sense. It'd be great. FDM is pretty well putting that in the plant model.
Yeah. Good question. Good question. I'd also say, having been involved with Ford in a long time, they certainly had some printers in plants before they decided, or before they built the advanced manufacturing center. So, as similar as James mentioned, General Motors with Oshawa, now they're building. So these things can happen, concurrently. And a lot of times it's those printers that have been in the plants that have been kind of the seed of what can be done out there on the manufacturing floor. Is that a fair statement, Jay, or are you okay? Right. So, are you yawning or do you have a question?
So Bob, I'm gonna ask you a question. I've been obviously at your facility many times. I've been involved in your workshops, and I know you have a lot of different kind of customers. I know you guys are working with Boeing and John Deere, obviously all the automotives. But do you see any particular industry that is really coming at you as far as additive is concerned? Maybe over and above. I know you're in Detroit, so it's probably more automotive. But what kind of industries do you see emerging that are asking for your guys' services?
The majority of the requests I've had lately have actually come from the food packaging industry. And a lot of it is they're really excited about additive, and they're like, oh man, this is going to be awesome, and it is. However, it's really that relationship is developing between me and the customer with, no, that's not the way we want to do it, we want to do it this way. So it's they have that preconceived notion of, oh, we'll just print it and it's cheaper, right? But it's not. Sometimes it is, very rarely. So it's what does this part need to do, and then we can, once we have that discussion, then we can say, okay, this would be the real cost of a 3D printed part that the food packaging company is really latched on.
Okay.
As of late.
Good. Stefan, the other thing we talk about when we talk to automotive groups is the tiered structure of the automotive industry. I know that we've done a lot of work with Ford about talking to their suppliers. They actually hosted suppliers that have gone to the Advanced Manufacturing Center. So we see the OEMs feeling like the adoption of additive with their suppliers is important. But in your business, do you see that OEM supplier connection, and how do you guys address that and leverage additive in that relationship?
Yeah, absolutely. So we see, obviously within the industry, the OEMs are really kind of trying to drive that down. The concern, and it was kind of addressed during the questions during my presentation, is that the adoption, even to the question Bob just answered, somebody will come to you and say, how much is it to print this? And you'll have a given cost, and when they compare that side by side with what they're paying today, it's going to be more. The problem is we need to look at it and say, what does it look like when it's printed, right? What are the key characteristics that we need to satisfy? And you can come up with a solution that probably does cost less, or at least the turnaround time is faster. But it's not going to look like what you have today, right? And that is probably the biggest hurdle from our perspective. It looks different than what they're used to, right? It's not proven. So how do you got to get somebody to buy in and adopt that and take the risk. So we see our role as the OEMs are doing it from top down. We're trying to push it from bottom up.
And how has the learning curve of your designers to really take advantage of additive? How has that been?
Sean, our engineering manager, is here with me today. It's been a slow process. It really is changing a mindset, for design for manufacturing, which really, has revolutionized the way machine build or machine tool has been done over the last 50 years. That we had the conversation over lunch, that CAD CAM piece, it wasn't that long ago. And really now we got to try to flip the table and reverse that course and actually design for additive versus design for manufacturing.
It looks from your examples like it's getting traction and you guys are moving forward.
Like I said, we wouldn't be able to run our business today. If our printer goes down, it's worse than half the staff calling in sick.
Yeah, would you say your printer is the employee of the month?
Employee of the month every month, yeah.
Okay. Please.
So Jay spoke mostly about end-use products for parts in vehicles, actually. But just from everyone's exposure to additive manufacturing, what would you say beyond the obvious speed and time would be the biggest hurdle for moving out of manufacturing into mainstream production as we know it, basically, with traditional manufacturers?
I will let Jay speak to and product use, but development of materials is obviously the key, and surface finish really is kind of what I would see as the challenge.
Just overall, and speed. It's just hard to build a lot of parts fast with additive. There's systems out there that are promising the world in the next year or so or two or whatever. We'll see.
We get asked often, what is the break-even point? When does it make sense to go into end-use production? And the sweet spot typically is low volumes, high complexity when you're trying to justify. But it's all over the map, and it's relative to one organization. 1 million parts is high volume. Another organization, 10 parts is high volume. So it really depends what language you're speaking. But it's interesting looking at the buying practices of various organizations. What I see in the aerospace or security and defense sectors, when they're getting pricing on components, they break it down to low volume numbers and how much would it cost to manufacture these parts. To give you share a story with you, one of our early adopters of the technology for end part production, we're looking to manufacture a fiber gut, and we're looking at Ultim 9085 specifically because of its flammability and V0 rating, because they're going to put this fiber guide inside an electronic chassis. And so one of our existing customers, they had a machine, and by being on site servicing the machine, the Ultim discussion came up, and so, hey, we're looking to manufacture parts. Can you guys quote us on 100 parts? So we quoted on the 100 parts. It was $6,000 versus $100,000 to CNC machine these fiber guides out of Ultim. And then I asked them, well, why 100 parts? Well, James, we really only need 6. But the quantities that we're quoting on, we're asking for 100 just so we can bring the piece part cost down to a point where I can get it approved. I go, so what are you going to do with the other 94 parts? Well, they're going to go on the shelf. We're never going to use them, maybe, but we only really need 6. So I go, why don't you just print 6 then? So that's when a light bulb went on for them. And they went back into their overall business and started investigating all the different projects and programs they had in place. And they got as far as 6 programs. And at that point, the justification to invest. So all of a sudden, the engineering department became a manufacturing department. And they, from now, they're in well over 100 components that they've cataloged that they're using their 3D printer for production. So it's something that you have to evaluate and assess on a case-by-case basis where it makes sense. We have many clients that are using end part production as a bridge to tooling. They know they're going to go to mass production, but timeline is such that the customer needs some components and we need to place them in a vehicle. We're holding up production. So we may start manufacturing low volume components. Each part's going to cost more, but the cost of delayed production or delivery of a program is much higher than what they're paying for these costs. Once tooling is done, then they'll go on to mass production. So additive manufacturing can also act as a bridge to the tooling application.
Thanks, James. John, you had a question?
Yeah. From an end-use perspective, we implement some of these systems around Canada, but from an end-use perspective, when maybe some people in the room are thinking of implementing this, any advice on how to drive adoption or how to have a strong startup when that machine shows up? Are there skill sets that you need? Are there certain things that you did that went really well? Are there certain things you tried and you would recommend in terms of getting the technology up and running to maybe the level that you did step in, or maybe Jay and Ford and Bob, you guys do well as well?
So when we brought the machines in at Eckhart, to go back a little bit further, I was told about an advanced technology center that we were going to open. And I told Andy, I said, hey, I grew up right there. I'd love to go back home. We were only living maybe an hour away. But we got to talking about it, and I said, what are you going to do there? I was a designer, an industrial designer. And I said, we're going to do everything we do here, but 3D printing. I said, I really like 3D printing. I I've got one at home. It's really cool, you know. And so that's, and he said, you know, well, let me talk to some people. And he came back and he said, Bob, you're going to be a part of the additive group at Warner. And I said, okay. Who else is there? And he pointed at the machines and said, here you go. So it was trial by fire, and at first I was afraid to fail. Like, oh man, if I screw up, I'm dead, right? I'm reporting to the CEO of this company. Never done that before in my life. I grew up in the shop floor, you know, so just to give you a little bit more background in my life. But then once I learned that failure was okay, as long as I learned from it and moved forward, that's the biggest thing that you really need to be willing to do is to be able to fail forward, as I say. Don't be afraid to try new things, but keep in mind that if it doesn't work, it's not the end of the world. Say, okay, well, that didn't work. Why didn't it work? And you have to apply those lessons.
For us, I try and talk the plants into either finding their most talented tool maker and getting him or her trained up, or put it in or near the CMM room, because the CMM guys are always looking for ways to fixture a part so they can check it repeatedly. So there's lots of immediate opportunities in those places, and then it can grow from there. Most tool makers, a lot of CMM guys also have a little bit of background in 3D CAD also, so that also gets you the next step closer to running.
Yeah, obviously 3D CAD is a huge asset. We're a user of SolidWorks, but really it's when you take additive manufacturing, it's as simple as printing to your Toshiba. The problem is you're not really giving you got to give some forethought to what does this need to look like with some functionality. Those really start to impact print time, print quality, and design. In the early stages, it was really just take it from CAD and print it, and now there's a little bit more fun.
Any more questions from the floor?
Do you guys do any post-processing on the parts aside from the obvious breakaway sports?
From our side, occasionally there's some machining or some inserting that can be done in the FDM process. You can actually insert during the print process, sanding, things like that.
Not a ton. Occasionally we get a request to paint a part or coat a part. We are going to be doing some more production parts that's going to require some sandblasting and some metal. I would finish there, but that's still under development. A little bit, but not a lot.
So for the most part, it is just basic support removal that we go through. There is occasionally put in a heat stake insert or with FDM, we can follow the bill for regular hex nut and reload. That's we try not to do it, but one thing that I want to mention is just because that part came up with very broke away the support, that doesn't mean that part is ready to go. That's I have some customers that say, once it's off the printer, then it's not great. So post-processing is a part of that part's manufacturing cycle. So it's an important step, and it's one that is often overlooked.
Typically, when you're manufacturing tooling, it's more focused on the function of that tool versus the aesthetics or appearance. So typically, you're going to do maybe a little bit of sanding, you do the inserts, but it's not really a cosmetic finish. That said, if you're looking to support the product development side, anything that you can do to plastic products today, whether you're blow molding or injection molding, rotor molding, whatever it may be, you can still do to a 3D printed plastic component. So you can do any nickel plating, vacuum analyzing, painting, so you can get it looking and functioning like a typically manufactured plastic part. But we're getting to the point where the solutions that our customers have are not just revolving around one aspect of 3D printing or one type of 3D printing, and the systems are getting faster. We're producing the parts quicker, and post-processing becomes a bottleneck. So we've expanded our solution set by bringing in different systems that enable us to do it very quickly and minimizing the direct labor associated with post-processing. So dissolving the supports much faster, looking at automation and deburring or polishing instead of sandblasting, maybe putting it in a vibratory tumbler so you get really nice smooth aesthetics. And that comes into play when you're handling that tool. So when people are touching it, maybe a sharp edge or something in that design is kind of knocked down through that process. So anything that we can automate, we'll automate. And removing that direct labor cost from the printing process is huge.
Okay, before we wrap up,
we have a F-170, and I often design to make sure that I don't use too much support material because I hate the post-processing, and I try to avoid that if I can. And sometimes I'll make pathways so I can break away. Now I've noticed sometimes that it breaks away easier than other times. I'm not sure if it has to do with the ambient temperature or whatever. Have you guys noticed anything in regards to the support material peeling off easier in some parts than others?
Yeah.
Do you know why?
I know because we have a 370, and if I print something out of ASA, the support material sticks to it really well. So it's almost always going in the back. If I make one out of ABS, I can peel it off. Maybe sometimes give us a better answer on that one, but it's yeah.
So the next question is, I sometimes stack parts and then run it over the weekend. So the gap between the parts is filled with support material. So I'll stack them in space. Have you done that before? And if so, what is the optimum gap so parts just kind of working? I have not tried that at all. Okay.
Well, it's not optimal. So you're going to be able to, if the geometry is such that you have, a clearance between the two parts of just solid support material, give yourself, doesn't have to be an awful lot, let's say even 50 thou. What's going to happen is you're going to break them, but there's still going to be support material against it, and that's going to dissolve away. Your options as far as the support creation is limited with the F-170. Like on the F-370, you can edit and modify your support structures any way you want, so you can mitigate that. But the fact that you're already taking into consideration the orientation or what you're designing to mitigate that. So when you're looking at designing for additive, it's not just can I use some tools to create this organic tool that's lightweight. You're also taking into consideration if you're lightening it, the features that you're designing will help reduce the support structure, eliminate the support structure. So it's about reducing the build time and also reducing the cost because you're using less material. So those are some of the things that the software is not going to be able to automatically create for you. Now you can take what the software gives you and go in and kind of modify the geometry a little bit, and with that in consideration. Also, the software doesn't know how you're going to use that tool either, right? So that's something that as a designer, taking into consideration how the operator is going to necessarily use it. And the advantage of additive is being able to remove, or not add material, just to give you that line of sight as well. So if you, let's say, a wiper alignment tool, if you print it and you place it over the wiper, now you can't see whether you're aligning or not. What's the point? So there are certain things that you want to have in that tool when you're designing it. But reducing the amount of support, specifically with FDM, is something that you're going to have to think about. So you're doing the right thing.
Okay. Any other questions? Okay. Well, I was going to let you do the wrap.
For Ford, you have tier 1, tier 2, tier 3. Your supply chain is very important to you. If you were to send a message to your suppliers about additive, what would it be? What would be the message that you would project to supply base today?
We've talked to a lot of our tooling suppliers about starting to adopt additive and offer the help. And we're offering, most of them will build parts at our place if they don't want to invest in a printer yet, just in order to get them walking down that road. And we think there's a lot of potential there. Just, like you said, in spare parts, I think there's a lot of opportunities there to not have to stock. Take up our general stores with parts that we can print, or just minimize the number more so that we can print as you consume them. So yeah, it's coming. So the more prepared you are, and the more knowledgeable you are, the better off you're going to position yourself.
So James, if there's no more questions, we're not trying to stop anybody from asking questions, but if there are no more questions, would you like to wrap us up?
Definitely. Well, thank you very much for taking the time out of your day today. I trust you found the presentations very insightful, and hopefully you can leave here taking something back with you as far as a spark or an idea that you can possibly investigate within your organization that may be able to implement additive and help you achieve your business objectives. It's never too late. And as much as our industry is approximately 30 years old, there's still a lot of growth potential. And I always try to provide some guidance to our clients is to don't wait. If you see an opportunity, make an investment. And we're not so much on the bleeding edge anymore. I remember the early days when you were buying additive, there were the early adopters, and they tend to be the large organizations that spent a lot of money, and they weren't necessarily receiving significant business benefits, but they saw that there was an advantage of leading the way. And today, with the technology being very affordable, you don't have to be a major player to play. You can, and I'm seeing it from a small little business, a mom and pop type organization, to very large global organizations that are making investments. And in fact, I'm seeing the early adopters implementing and achieving significant success. And they tend to move much quicker when they're making their investments. They see a solution, they know its capabilities, and they act. And it's usually the large organizations are a little slower to move, sometimes slower to adopt. But that's changing. I think because it's competitive nature for everybody. So it doesn't matter who you are. You're seeing an opening, you're seeing a window, and I encourage you to investigate. Now, some of you who may have looked at 3D printing and come or walked away saying, oh, they're not ready, they can't help me. And there's a lot of companies like that or individuals out there today, and I try to encourage them to say, it may not be right for you today, but it doesn't mean that you stop looking or stop investigating. It should be just part of your culture within your organization to continue looking for ways to improve. And things change in our industry. New materials may be launched, new systems capabilities, more applications get developed. So it's something that should be considered on an ongoing basis. I'd like to thank our guests today. The information was very beneficial. I saw some really great things, even though I think at this point in my career that I've seen everything. But I'm encouraged what I hear, and I really appreciate you taking the time to support our event because I know you value and see the importance of the message that you're sharing today. And the more we spread the successes, maybe we can encourage many more people to take that next step. So instead of just dipping your toe, dive right in. And as organizations, Cimetrix, JAvelin, and Stratasys, we're here to help expedite that process and to help reduce or mitigate that extended learning curve when you're trying to adopt additive into your business. Gentlemen, thank you. Thank you very much for attending.